So guys, now let us discuss what are our aim or goals that we are looking to achieve in this section of the course. So we are basically looking to implement CRUD operations, which when performed by multiple threads in the system concurrently, then the integrity and consistency of our data structure is guaranteed. So we are looking to implement CRUD operations over data structures, and those CRUD operations are not only thread safe, but also at the same time ensure maximum concurrency as possible. Alright? Maximum concurrency means thread must not unnecessarily block each other in an attempt to get an access to the resource. Here resource means data structures. So threads performing read operations must not compete or block each other to get an access. We have already discussed that. Read operations is one of the most simplest operations among all those four operations. And we already know that read-read operations are non-conflicting operations. Any number of threads, let's say T1, T2, T3 up to Tn, if they are performing only read operations on any node of this linked list, then all these threads must be allowed to execute in parallel or must be allowed to get an access to the linked list without blocking each other at all. Then if the thread T1, some thread in the system, let's say T1, perform read operation and some other thread in the system T2 perform write operation on any node of the linked list, then they must not block each other unless they perform operation on the same student object. So it makes sense that if the thread T1 is performing read operation on the student whose roll number is 2, and the thread T2 is performing write operation on a student whose roll number is 3, then I don't see any reason that why thread T1 must block thread T2 or why the thread T2 must block thread T1 from getting an access to the linked list. They can very well execute in parallel. But they must block each other if both attempt to perform an operation on the same node of the linked list, that is on the student whose roll number is 2. Alright, because read and write are conflicting operations and only one must be allowed to execute on the same student object at any given point of time. Then the third goal is that if the thread T1 perform write operation and the thread T2 also perform write operation, then they must not block each other unless they perform operation on the same student object. So it's the same story. Just like read and write are conflicting operations, write and write are also conflicting operations. Alright. Fourth point says that if the thread T is performing either a read or a write operation on an object, that is, if the thread T is performing read or write operation on some student object in the linked list, some other thread in the system must not free the object memory prematurely. So it simply means that if the thread T is performing either read or write operation on the student whose roll number is 2, then any other thread in the system, let's say T2, if delete or free this student memory whose roll number is 2, then it means that the first thread T1 would end up performing read or write operation on the student object which do not exist anymore, because some other thread in the system has freed that memory. So it means that the thread T1 would end up performing an operation on a memory which has been freed. It means that your program is wrong, it may end up with any undefined behavior, or it can crash or segment fault can happen. Alright, so we will need to avoid this situation. Similarly, if the thread T is blocked on some mutex or lock, let's say X, then some other thread in the system must not free the lock X memory. Alright, so we have the thread T1 and let's say the thread T1 is executing happily, and let's say that the thread T1 is blocked at this point because the thread T1 wants a lock on the mutex M, but the mutex M is already being locked by some other thread. It means that the thread T1 would be in the blocked state here. Alright, Now, while the thread T1 is blocked on the mutex, some other thread in the system, while executing, destroy or free the mutex M1. So it means that the thread T1 would end up blocked on the mutex which do not even exist. Alright? And it is again an undefined behavior in the program. Your program may crash, it may segment fault, it can end up anywhere. Alright? So it simply means that while the mutex M is logged, no other thread in the system must destroy that mutex. So we will going to design our CRUD operations such that all these rules are strictly followed. And whatever rules we will going to discuss, those rules are equally applicable on any data structures or any multi-threaded applications with any number of threads or any number of data structures. For simplicity, we have just taken linked list as an example.